Hello everyone, and welcome to Lesson 19, Cognitive Processes, Attention and Perception. Let's start with a video.
This is a test of selective attention. Count how many times the players wearing white pass the basketball. How many passes did you count? The correct answer is 15 passes. But did you see the gorilla? This video is from research by Daniel Simons and Chris.
By the end of this lecture, you'll be able to explain implications of attention and perception on interface design, discuss pre-attentive processing using visual variables and degrees of difference, list and describe 5 principles of Gestalt psychology, and critique and suggest improvements to an interface using theories of attention and perception. Let's talk about cognition. Cognition is what goes on in the mind. It includes activities like perceiving, thinking, remembering, and learning, and can be organized to things like planning a meal, imagining a trip, painting, writing, or composing. It involves understanding others, talking, and making decisions, daydreaming even. All of this is what's going on when we talk about cognition. There are lots of cognitive processes, all of which are relevant for HCI. Today, we're going to focus on 2, attention and perception, that will really help you organize interfaces and systems that have some sort of interaction with a human. So the first one we'll talk about is attention. Have you heard of the cocktail party effect? Let's take a look at another video.
What is the cocktail party effect?
It's this phenomenon where in the midst of a noisy cocktail party, any kind of noisy sporting event or newsroom, we're still able to focus in on the one conversation we want to hear and somehow tune out everything else.
And how can, now researchers, neuroscientists are very interested in this. Why is that? Why do they want to know where this ability comes from?
It's part of this whole phenomenon of selective attention, wherein the human brain can only really focus in intensely on one thing at a time. And this is a survival skill. You know, we're constantly bombarded by all this visual and auditory stimulation. We couldn't survive unless we could focus in like this, but we can also only really focus on one thing at a time. And that's what's at issue in distracted driving and all kinds of other limitations of multitasking.
Are there people who, is there like a small percentage of people who actually have sort of a super ability to focus on more than one thing, or is that a myth?
Yes, researchers at the University of Utah have found some of these people in the course of their other research. They think it's about 2% of the population. The real problem is that most of us think we can do that, and that can have some disastrous consequences.
The cocktail party effect is another example of selective attention. Now imagine you're in a room having a conversation with your friends about how much you love your Introduction to Psychology's Udacity class and how everybody should take it. Then, all of a sudden, you heard your name from across the room. In this example, you were selectively attending to the conversation you were having, yet still heard your name across the noisy room with a bunch of other conversations going on. So, you were able to filter out the background auditory stimuli that wasn't important. That was that background conversations. Yet, you were still able to focus on the important stimulus that was your name. So that background information came to the foreground.
Did you notice that the speaker's appearance changed? Oftentimes, this one doesn't hit as hard as the gorilla one, and you're probably on guard, but hopefully I got some of you. Attention is selecting things to concentrate on at a point in time from the mass of stimuli around us. It allows us to focus on an information that is relevant to what we're doing, which means it can be very goal-driven. For example, with the cocktail party effect, you can really hone in on something that you want to pay attention to. Or if you're driving, you can focus on parts of the road and making sure you periodically check things around you. It usually involves audio and or visual senses. And it can be focused and divided attention enables us to be selective in terms of mass competing stimuli, but also it limits our ability to keep track of all events. So you have to be aware of this when you work with an interface. So we're going to do a your turn. We're not going to have any submissions this time. This stuff will be captured in assignment 5. So you can kind of take this and use that in the assignment. So when I say go, I want you to find the price of a double room at the Holiday Inn in Bradley. Are you ready? You don't need to pause the video or anything. Go. Found it. Okay. Now we're going to do the same thing. We're going to try and find the price of a double room at the Quality Inn in Columbia. Ready? Go. Done. Which of those things was easier? Toulis in 1987 found that these produced quite different results. The first screen took an average of 5.5 seconds to search, and the second screen took about 3.2 seconds to search. Why is this the case, since both have the same density of information, about 31%? Spacing. In the first screen, the information is bunched up together, making it hard to search. In the second screen, the characters are grouped into vertical categories of information, making it easier. So how do we use this to design interfaces to make good use of our attention? Well, information in our interface should be structured in a way to capture users' attention. For example, using perceptual boundaries, windows, color, reverse video, sound, and limited animation or flashing lights. And the way that you can think about a lot of this is by thinking of salience. Salience is how apparent something is. And often it is pre-attentive, which means prior to conscious attention, which you can direct. We want to design elements that pop out so that they're noticeable at a glance, particularly for time-critical interfaces. There are two primary factors for visual target selection. The first being the degree of difference between the target and non-targets, and the second being the degree of difference between non-targets and other non-targets. Jazz agrees. Well, we'll cover this in a second. First, let's talk about pre-attentive processing. This is processing of visual information that is performed automatically on the entire visual field, detecting basic features of objects in the display, things like colors, closure, line ends, contrast, tilt, curvature, and size. Pre-attentive processing is done quickly, effortlessly, and in parallel without any attention being focused on the display. How effective this is depends on various visual variables. Variations in color, size, texture, shape, and pattern make a difference in how much things pop out. Visual variables can be used to design salient or easily visually selectable information. These are the main visual variables that you have to work with. Value, which is how dark or light something is. Hue, so what color it is. Texture. Shape. Position. You can see the two are kind of clustered together and one is separate. Orientation. And size. And each of these has a different priority in your visual attention. You can think about selectivity, the degree to which a single value of the variable can be selected from the entire visual field. On the far right, we see a bunch of different circles, and those are quite distinct from the T's that are located. In the middle, we see T's and L's. They're a little bit separable, but it takes a little bit. You have to kind of think, oh, okay, I'm noticing that corner edge, but the actual line is harder to identify. And then the far left, we have a set of T's, and we have a couple that are inverted, right? So half of them are inverted, half of them aren't inverted. And that can be more challenging to figure out. And if you have something like color, it can pop out amongst the entire field. Detecting the red object is done pre-attentively. You look and you automatically see it if you're able to see the screen. There's one visual variable, and it's very easy to find it. But if you have a bunch of shapes, all the same color, detecting the circle is pre-attentive, maybe a little bit less so than color. It's more difficult, but it's still pre-attentive processing. It still pops out at you. So let's do this interactively. When I say go, I want you to time how long it takes you to find the target. Pause now if you need to get a timer, for example, on your computer or on your mobile device. And then when I say go, see how long it takes you to find the target. Ready? Go. You probably found it by now. We'll do this one more time. Ready? Go. Here, there's a different degree of difference between the target and the non-targets. So let's talk about degree of difference. In A, the target can be detected pre-attentively because it possesses the feature filled, and everything else has non-filled. The degree of difference between the target and the non-targets, what do you think that is? Is it large or small? It's quite large. The target has this property, all the non-targets don't. And the degree of difference between the non-targets and each other, is that high or low? It's low. All of the non-targets have exactly the same property. They're visually identical. And so it makes it so that the difference between the target and the non-targets is much higher than the non-targets versus each other. With B, the target cannot be detected pre-attentively. It's because it has no visual feature that is unique from its distractors. It shares both the filled property with the squares and the shape property with the circles. So the degree of difference from the target to the non-targets is smaller, relatively speaking. It's only got one variable different rather than two that would really make it stand out. And the degree of difference between the non-targets and each other is quite high. Let's take a look at another example. Can you find Ed Sheeran? You can, even though there is a bit of a degree of difficulty with the background. There is a low degree of difference between the target, Ed Sheeran, and the non-target, Leaves. They share some similar characteristics. But there's also a low degree of difference between the non-targets. There's a little bit of variance in size, but most of the leaves look quite identical. So you can identify the target, Ed Sheeran, with only a little bit of difficulty. These are the various variables that are pre-attentive. We have orientation, we have curved versus straight, we have shape, a couple different ways of looking at shape, size, number, the grayscale or value, enclosure, convexity and concavity, addition, adding an extra visual feature, juncture, and parallelism. And some of these pop out more than others. And in some cases, you could really combine these to make it sort of dual encode it to make it pop out even more. We can use this to reduce clutter in our interfaces to make things that are important or information that should be salient more salient. So take a look at this interface. You can see that it's full of graphs and bars. There's a lot of information there, but a lot of it's the same size. There's a lot of similar bar graphs, so it doesn't make things pop out very much. Versus this interface. Obviously, there's less information, so you're already focusing the attention on what's there. But you also have things, there's quite a bit of variety in the size. For example, the numbers that are in the plot are quite a bit larger than the numbers that would be below on any of the detailed views. So some design implications from attention to consider. Attention is a resource. You want to make information salient to get the attention. And you have a set of techniques that can let things stand out to help you direct someone's attention to where you want it to be. You can take advantage of visual variables, but some visual variables stand out more than others. But you need to be selective in providing salient features. If you have too many of them, it can clutter the interface, meaning that there's a lot of visual noise coming in, and people won't be able to find the targets versus the non-targets.